So, thanks for tuning in, Twitch chat, and everyone who is watching later on YouTube. Today we have a Leetcode mock interview here with us. Today our candidate is Qingyun. Thank you for volunteering. Do you want to give a quick introduction about yourself?
I'm currently studying computer science in University of British Columbia, and I'm now in year two. Yeah.
Second year. Awesome. Great. Okay. Let's get right into it. No need to dilly-dally. So you're in the coder pad, right? And let me just, yeah, you're in. Okay, great. So we'll be doing a Leetcode today. And depending on how it goes, we might do a couple follow-ups or some other problems. For this problem, I want you to write me a function. So you can write me just a function under the solution class. That's fine.
Okay.
To implement a function called power. Okay, power will take in two inputs, both numbers. Okay,
Mm-hmm.
it will take in the first parameter will be a base. Okay, that'll be a floating point number.
Mm-hmm.
Okay, and it'll also take in an exponent. Okay, that will
Mm-hmm.
be an integer. Okay, so base is going to be a float, and then or a double. A floating point number depends on the language. It could be float or double. That's up to you to pick.
Mm-hmm.
Okay, and then the exponent is integer. Okay, and I want you to
Mm-hmm.
return me the power of the base to the exponent.
Okay, so it will be an double.
Yep, that's the reasonable return
Mhm.
type. Yep.
Oh, may I ask, can I use math class because Java has math class that can achieve these method?
In this case, I won't let you use the math class. That would be too
Okay.
easy.
Yeah. Sure. Okay.
But it's good that you know it, so points there.
Mm-hmm. So that I will write static method because I want to just check that within the uh, class solution. So yeah, you will have to. Mm, my strategy of
Mm-hmm.
using this of these of achieving these goals is just like I have a return value which is a double.
Okay.
Uh, yeah, and I will return this value, and then I will in increase the value of RST by multiply it with the base with the number of base. So
Okay.
I will run a for loop.
I think you might need to initialize the return value.
Okay, I check it with zero. No, not one. It should be one. Yeah, and let me check my code.
Mm-hmm.
Yeah, for that, if this so then I will write a test case. Or can I
Yeah, yeah,
delete
go ahead.
all?
Yeah, yeah, yeah. That's just a boilerplate that came with the sample Java file, so you can delete everything.
Okay. Do I need to write a JUnit test or
No.
just to write
Yeah,
in
just
the
calling
math?
it is fine. Honestly, most of the time, if it's a more complex problem, I won't even ask people to write real code. But
Mm-hmm.
it's okay to just write it right. Just write some simple Java code. Yeah.
Okay. 2 to the power of 3, which is 2 times 2 times 2. So that for this test, it should return 8.
Mm-hmm. Do you wanna
8,
yeah?
yeah.
Do you wanna
Yeah.
print that out as well?
No, just I will save this
Okay.
value so that solution the okay, zero. So then I will just so this is my test. Did I run it now?
Yeah, go ahead.
Okay. It works well with my test. Maybe I will check another one just to add some edge test. And it like oh, I didn't consider zero in this case. Maybe that's a problem. Yeah. I didn't consider it, so I will fix my initial code.
Okay.
Yes, and
Just a quick question on this before we move on. If the base is 0, what are we
yeah.
returning in this case?
Just if it's zero, so that I should return just zero.
Okay.
Yeah, and I also think there is also a problem in my code that I didn't consider the negative value. Yeah, if the expo is a negative value, I didn't consider it. So there's still some minor mistake in my code. But I'm definitely sure that this test can works well as I expected. So that it should return zero. Yeah, it returns zero. Yeah.
Okay.
But for negative input, I should fix my code. Yeah. Let me think about it. If it's negative value, okay. So that I should also consider another situation. If expo equals to negative zero, so that I will also run a for loop, but the result will so and the result will be should be divided by 1. So I think maybe I can just try it that way. Expo is greater than 0. If it's greater than 0, I will greater or equal to 0. Then I will write 1. Okay, just result. Or if it's not, I will return this one.
Okay.
Yeah, and I also need to write another case. Change. In this case, it should return. Yeah. this value. So let me run my code. Oh, okay. Oh, there's something wrong with it. I should change 1 into 1.0 because if it's just an integer
Mm-hmm.
and the integer divide an integer, the return value will just be an integer.
Mm-hmm.
So
Okay.
it will it will neglect the value that behind the point. So I will try it again. Oh, what's wrong with it?
So the 2, -3 case is giving some trouble right now.
Mm-hmm.
Mm-hmm.
Yeah, there's some trouble in there.
Okay.
I'm thinking about maybe.
Think about your for loop.
Yeah,
What is expo in this case?
exponent. Oh, exponent is there is oh, it's a negative value,
That's
so
right.
it oh, okay, okay, I get. Okay, that's so that I have to write a if statement. Um, 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 what's this? Yeah, I'm trying to change the expo into a positive one
Mm-hmm.
if it's an because that I otherwise that it will not run into the for loop. So I
That's right.
will change the value of it. But actually, I'm not sure this one works well for like very big numbers because sometimes you just but yeah. But for this case, I think oops, it still doesn't run as what I expected.
What is expo in this case?
Oh, oops. Okay, I see. Okay. 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 Thank you for pointing out. I should not play off my mod here, so I have to write it. If expo is double, return just the else. I will just write it. Just copy this code here. Yes, I will return the result.
Mm-hmm. Let's have a look.
Let's see. Else if else. Mm, Let me check my code. This one works. Okay, it works as expected.
Nice. Great.
Mhm.
Um, I had a let's see. What if so you have if expo is less than 0, you have this case
Mhm.
as a default case. is there any
Mm-hmm.
special consideration that needs to be met if the exponent is equal to 0? Or does your code also work in that case?
Because I was think that if I didn't consider expo is greater than 0 or less than 0, I will not let base case to uh, be multiplied into the final result. For in that case, that if expo is less than 0, it will not run into this for loop in this case.
Mm-hmm.
Yeah, it will
Okay.
not run into the for loop. So that I need to first change the expo into a positive value, and then so that it can increase the final result by multiplying it
Mm-hmm.
to the result.
Yeah. Yep, that looks good to me.
Mm-hmm.
Let's spend a bit of time here and talk about the time and space complexity a bit.
I will think the time complexity will be ON because there is a for loop there, and
What is n? Let's be clear about this.
and there is the expo.
Mm-hmm. Okay.
Yeah, and
So is that
the
time? Is that the
yeah,
timing?
it's
Okay.
the time complexity.
Okay. And how about the space? Is there any space complexity? What's the space complexity here for this function?
I will think the space complexity will be O1 because there's no extra array or lister as created in this function. Just I just create the value of result.
Mm-hmm.
That's the only thing that I create. So that the space complexity will be O1.
Mm-hmm. Okay. Yeah, that's good. That sounds good to me. Um, you alluded to this before, just a moment. Let me just quickly write this down before I forget what you said. Okay.
Mhm.
Um, so I think you alluded to this just a moment ago, that this might not be the most efficient way to do this. Uh, and I think that's right. There are some ways to improve this. So let's spend a bit
Okay.
of time and think about how we might be able to improve the time complexity of this function. Okay, now I will say that in this case, you have optimized the function for space complexity. There's no extra space used. And in fact, there's actually only one piece of memory being used. So you basically declare just one double, which is as little memory as it gets, which is good. Um, but let's talk about, if, for example, I'm not as strict with space complexity, but I want to really minimize time complexity. What are some ideas that you have for this?
Uh, I would think although I don't have a very good way to solve it, but I will think about maybe I can record like base, for example, with the Expo 2 or with Expo 3, so that I don't need to, for example, if I want to, uh, uh, for the case that if it's just like 2 to the power of 5,
Mm-hmm.
I can just if I can save the 2 to the power 2 to the power of 2, if I save it, so that I just need to multiply it with power 2 2 and also like power 2 1, so that it will save the time complexity because I don't need to multiply
Mm-hmm.
2 times 2 many times, so that it can be like log n with the
Okay.
time cut. Yeah.
Okay. That's a really good start. Um, how would this approach work if there was a different base though, right?
Mm-hmm.
If, for example, so this would work great if I only gave you base 2.
Mm-hmm.
But if I, for example, gave you base 2.8, how would that work?
Base 2.8. I don't think the value of base will matter that much. What I need is
Mm-hmm.
uh, just like to divide the expo. for example, in this case, because the expo is an integer in this case, so that it can either be an even number or an odd number. So that it can be the result of many.
Yeah,
Uh,
I
yeah.
think you have a good direction here. Why don't you go try to implement that? So let me just quickly save your current piece of code. You can delete that and continue now.
Okay. I'm just thinking about like the data structure to save that kind of value here. So let me think. Mm, so that I can. I'm thinking maybe if expo is a very small number, for example, if it's just less than 2, I don't need to do the following things. Or less than 2, but it should be a positive number. Because that you just need to say, yeah, you just need. Okay. So I would think that I will need to have a value to save the base case to the power of 2. Yeah,
Okay.
I'll save. And I also will try to find out the how many times I should, and also this one. And I also need to find out how many times I need to how many times I need to multiply result with value, because that in this case value is base times base, so that it should be expo, yeah, divided by 2. Because that is just it is just the integer divided by integer, so that it will just return the integer value without the uh, an integer value, and I will also save the remainder of expo divide by 2, so that yeah, and in this case it should be either 1 or 0. And to solve these questions, I will also like run a for loop. I will first just solve this question by assuming the the base is a positive number, and I will, if my code passed my test, I will add the consideration of the negative value.
Yeah, that's fine.
Okay. Int less than n I plus plus times value. Yes, in this case it should be better. If remainder is greater than 0, I will also let the result expo again. Oh, sorry, it's not expo. It's a base. Base again. Yeah. And
Okay.
yeah. So I also need to. I will also not consider the 0 point. Just want to check if my code here works well.
Yeah, we can just
Mm,
consider the happy cases for now.
okay, cool. Let me check my code. It should be good. Yeah. Okay, it runs as what I expected.
Okay. I want to just
Yeah.
pause here really quickly and ask, what is the time complexity now?
I will think the time complexity will be log n and n here is expo.
Can we double check that? So how many times are you looping?
Um, I loop the
In times, and what is n equal to?
oh, sorry, it's still expo, so I didn't increase the time complexity here.
Mm-hmm. So it's still linear time, but it's half
Okay.
linear time. Okay, that's
Yeah.
an improvement.
Yeah.
Um, okay, let's think about this a bit more. This is a really good piece of intuition here. Okay,
Mhm.
now unfortunately that's not log time yet,
Yeah.
but it's one of the steps there. Okay, so
Mhm.
let's think about what it means to do, and let's keep the math simple for now. Okay, so let's say we're doing 2 to the power. Let me think. Let's do 2 to the power of 5. Okay,
Yeah. Mhm.
and this is what you're doing here, which is good. Um,
Yeah.
the easiest way to make this log time or to have an exponential time reduction is to split the problem into two equal sizes. So that
Oh,
is distinct. Actually, this is get confusing. Let's do it this way. No, let's do it this way. We'll do 2 to 8. The reason that what I mean by two equal sizes, this is distinct from what you're doing because you're not
mm-hmm.
splitting the problem into two equal sizes. You're splitting it into in divided by two equal sizes. So you
Mm-hmm.
are using the base value, like the base value of 2 to the power of 2, right? Let's
Yeah.
not do that. Let's instead break it down to two equal size problems. What's two equal size problems? So you had the right math for this. Two equal size
Mm-hmm.
problems is 2 to the 4, 2 to the 4. And
Mm-hmm.
how do you get 2 to the 8 back? You multiply them together, right? This math that you know. Okay?
Yeah.
So now we have broken 2 to the 8 into two equal size
Mm-hmm.
problems. Do
Mm-hmm.
you see?
Oh,
And
so
then we need to do that one more time because 2 to the 4 is still not an easy problem. So we need to break it down one more time. So how would you break down 2 to the 4 into two even problems?
I will think that I will also break 4 into two, so that it will be like a binary tree, like something
Uh-huh.
like that.
Can you just write the comments for me at first just so we can get on the same page?
Okay,
And you
cool.
can make room if you need. This might be a bit cramped.
Mm-hmm. Mm-hmm. Here and here. No, it looks ugly,
I
but
think you're missing one more over here, right? 2 to the power 2 here. Oh, that works too. Okay.
mm,
Go ahead.
yeah, it looks ugly,
It's
but
okay. We'll fix
yeah.
it like this. We'll fix it in post. Don't worry. Okay, there we go. Yeah, so this is now we're solving 2 to the power of 8. And each
Mm-hmm.
level, we've broken it into two problems of the same size. Because
Okay.
the difference between what we've done here and what you've done here, the difference is that each level down is a fixed number of subproblems. Right? Your number of subproblems here scales with n. For example,
Yeah.
if this was 10 instead of 5, you would have twice as many subproblems. See, that's not an exponential time reduction. If this was 16 instead of 8, we would still have two subproblems here, but we just have another
Mm-hmm.
level. right? So
Mm.
doubling the size of the problem only increases the size of our calculation by 1. So that is the exponential time reduction we're looking at. Now, so does everything make sense about that so far?
Yeah, I'm actually thinking about how to record these numbers.
Okay.
Maybe I can record it into an array.
Mm-hmm.
Yes,
We can
just like mm,
we can keep this pretty simple for in terms of
mm-hmm,
recording the value. Have you
mm-hmm.
used hash maps before?
Yeah.
Great. Yeah. So notice that in our power, all the bases are the same. Obviously, right? The bases are the same. The only thing that's different is the exponent. Okay. So why
Mm-hmm,
don't we store a map? So this is good intuition for me as well. So let's store a map. Okay.
mm-hmm.
Okay. And the key will be the exponent. Key equals current exponent. So in this case, it'll
Mm-hmm.
start. I'll start at 8, right? And then so this
Yeah.
could be so first it'll be 8, and it'll be 2, and then it'll be 2. So your keys might be, for example, right, this example 2, 4, 8. Okay. And the
Oh yeah.
values are going to be the value of equals base to the power of expo. So this case will be 2 to the power of 2, which is 4, 2 to the power of 4, which is quick math 16, and 2 to the power of 8 is 256, I think. Right? So these will be your
Mm-hmm.
values. These will be your keys. Does that make
Mm-hmm.
sense?
Yeah, it makes sense.
Great. And then one more thing I want to touch on before I let you implement this, which is this is obviously an easy case, 2 to the power of 8. Let's think about
Mhm.
another case, okay, which is 2 to the power of 11.
So,
Can you
yeah,
can you
that's
can,
an
can you write down the subtree for me here? Or
yes.
can you help me think about how you might approach this?
2 to the power of 11. I will think maybe I can divide 11 first with 11 with 8 plus 3 so that I will solve the 8 part with the same problem here,
Okay.
and maybe 3 is another case. Will be okay?
That would be okay, but let's see if we can make the tree even shorter. Right. So in your example, if you have 8 plus 3, that would be correct. That would produce the correct answer.
Mm-hmm.
But 8 and 3 are not equal sized problems,
Yeah.
right? And so therefore the height of your tree will be unbalanced. Does that make sense?
Yeah.
Right. So I mean,
Yeah.
for example, you say 8 and 3. We could do, for example, 10 and 2 or 10 and 1. It's still correct, but it's not really going to help you, right? So how can we split 11 to be as even as possible?
Um, as even as possible.
Yeah. So you
So,
might you might need three children in this tree, for example. How would you make it
oh,
as even as possible?
I would think maybe it's impossible to divide an odd number into several even number because the sum of even number will always be even number.
That's true. And so we won't have two subproblems here. We can have three. And so in this case, I propose we divide into 5 plus 5 plus 1. Why is that still okay? The reason is because we still have a fixed number of children. If we divide it as evenly as possible, we will never have more than 3 children per level. And therefore, it will still be a logarithmic time reduction.
Yeah.
So you can do, I think in this case, doing a 5, 5, 1 will be the easiest. So if it's an odd number, I propose take 1 off, so make it
Mm-hmm.
-1, and divide by 2. Can you sketch out what that would look like?
Is it looks like that?
Yep.
That and something like that first
Yep, that makes
line.
sense. Uh-huh.
Yeah.
And then how about the next level?
5 will be 2 and 2 to 1.
2, 2, 1. Yep, that's correct.
Yeah. And same thing here. Yep. And also for this one, it's just copy it
Mm-hmm.
here.
Cool. Yeah, that looks good to me. Let's implement this.
Mm-hmm. Oh, so I will only need to hash map for. Mm. But I'm wondering why you need a hash map because
That's a great
because you
question. The reason is
yeah.
because when you want to calculate 2 to the 11, you would
Mm-hmm.
divide three subproblems. 2, 5, 2, 5. Okay, for now on, I'm just gonna say the exponent, okay? Because the bases are all 2. So if I'm gonna calculate
Mm-hmm.
11, you need the 5, 5, and 1 subproblems, correct?
Mm-hmm.
Now you don't know the answer to any of these, so we have to calculate the 5 subproblem, okay?
Mm-hmm.
Now the now you're trying to calculate the 5 subproblem. The 5 subproblem requires 2, 2, and 1 subproblems, okay?
Yeah.
So you don't have any of these answers either because you haven't seen it before. So you have to just do the math. So you just do the math, blah blah blah. You do the math. Now your map will contain 2 equals 4 because 2 to the power 2 equals 4, right? And
Mm-hmm.
1
Yeah.
equals 2. Well, okay, well these ones you don't really need to store because this is just math, right? But so this is what your map can contain, right? And then
Mm-hmm.
now you have all the subproblem answers. You multiply them together. So 4 times 4, right? This is 4 times 4 times 2. What is that? 32, right? 4 times, yeah, 16 by 2. So now you know. So now you also know 5 is 32. Right? So now this value goes to 32. Now guess what? You now try to calculate the second subproblem of 2 to the 11, which is also 2 to the 5. But you don't need to calculate 2 to the 5 because it's in your map already.
Yeah, you can just
So you only need to calculate the values you haven't seen before. That's the purpose of the map in this case.
Okay, that's cool. Actually, I'm just thinking about maybe an array and the integer and the index may be the key here, and the value is same as a hash map's value. But I would think that your way may be more efficient because you don't need to store the other mm,
Yeah,
other value that you don't need that.
that's
Yeah.
right. Yeah.
Okay. I'm thinking. But how can I divide the value?
So for the purpose of this,
Mm-hmm.
we don't have to write proper Java. I just want to see you
Mm-hmm.
write some pseudocode. I just want to see you
Okay.
write the thought process out in a bit more code. Because we've only drawn some diagrams so far. It's a bit too abstract. But
Mm-hmm.
I don't need perfect working Java code here. We won't be running this. I just want to see you write some algorithm down.
Okay. I will first. I also will have a result set into one, and this is the result that we have, and also I will also like I'm thinking about how to divide the expo. The expo here divide into 551, and is it better that we divide it into two similar or two same value and yes and one okay I will think that for the first line it will just be for this case like 5 is equal to 11 plus minus 2 so that I will first generate the key here and int key will be expo divide by 2. This will be the first key, and I will while key is 5 divided by 2. It will be in here. I also have 5 divided 2 equals 2. So mm, yes, I will first while key while key is greater than 2, I will always run key here. Yeah, so that this will be the key that I will save into hash map.
Mm-hmm. We can be if you want, you can write some pseudocode. I don't need full Java syntax for this.
Okay.
Yeah.
Uh, I will first just like something choose. I will put the key and put the key and the value here. The value will be, will it be better if I start with the, yeah, I can start with the small number instead of the big number, 5 here, because that a 5 here can be the result of 2 times 2 times. But yeah, so
You can
maybe I
start. Yeah,
can,
it doesn't really matter if you start from the top or bottom. But one thing you do have to be aware is that if you want to start from the top, like 5 or 11, um,
yeah,
you can't actually put the value into the map because you don't know the value. So
yeah, it's so that I will start with the small number first, from the bottom to top.
sure, yeah. So let's say this. So you can say start at a small number.
Smaller number from bottom
Okay.
to top.
So your step one would be start at what? Start at two to the power of one, or let's say right to the power
Yeah,
of one and two to the power of two. Okay.
and I will check if expo is if expo is greater than 2, and if its expo is greater than 2, maybe I can. It's better to save it into key into expo, and if key is greater than 2, it means that I still need to uh, continue to do the multiplication, and the result, the value will be,
Right. So you're. Oh, okay.
yeah, oh sorry, it will be value get value from the map hash map, and with the power with the key. Oh no, it's not like that. I should first find out if
It's
it's.
pretty close. I think one thing we're missing here is that if you want to build the solution from the bottom up,
Mm-hmm.
we can start like super easy, right? So for example, if you know that um, if you know that for example you have 2 to the 11, you know that
Mm-hmm.
you can first calculate what subproblems you'll need to make, right? So for example, in this case, what I'm saying is that to calculate 2 to
Mm-hmm.
11, you don't need to know 2 to the 10, even though that is technically one less than 2 to the, you don't need 2 to the 9, don't need 2 to the 8. Like you don't need all of these subproblems, right? You only need some of them. So which subproblems do you need? To calculate 2 to the
Mm-hmm.
11, you need subproblems 5 and 1, right?
5 and yeah, 5 and 2 and
You need
1.
you need 5 and 1, right? To calculate 2 to
Yeah.
11, If you had the answer to 2 to the 5 and 2 to the 1, you can calculate 2 to the 11, correct?
Yeah.
Right, because you just multiply 2 to the 5, you multiply by itself again, and then multiply by 2 to the 1. And in this case, so let's just say, so this case, we can also say, start a different idea here, right? To calculate 2 to the 11, we need 2 to the 5 and 2 to the 1, right?
Yeah.
So we can say, and as essentially for 2 to the 5, we need 2 to the 2, 2 to the 2, and 2 to the 1, right?
1. Yeah.
So at any given stage, as long as we can figure out what subproblem we need, we can just go calculate that subproblem.
Yeah.
Okay. A pretty easy way to think about this, and now we'll just talk so there's no more code now. So let's just talk about some of the ideas for this one, right? So in this case, just to talk about what's going on here, if you think about it, if you zoom out a little bit, the big picture, right? This power function is able to take any input, right? At any base, any exponent, right? We can call ourselves recursively if we need to solve a subproblem.
True.
So, for example, for 2 to the 11, we can call ourselves and say, hey, why don't you go figure out 2 to the 5 and 2 to the 1? So we can just say this, right? Pow 2 to the 11 equals pow 2 5, right? Times pow 2 5 times pow. I'll write 2 to 1 here, but you can just calculate this yourself, right? Right?
Yep.
So this is the intuition here that was a bit of a difference, is that we can just break the subproblem off by calling ourselves. Now, one detail that this doesn't cover is how do we prevent ourselves, because like these two trees can be very, very big. If it's not 5, it could be 50, right? Very big trees. How do we prevent ourselves from doing the double amount of work? We can put this is where the map comes in, right? We can put in a third parameter, which is our cache, right? And so in this case, for example, inside of our implementation, so our pow, right, our implementation, this is not how I write code, this is just pseudocode, right? We can say, this is, for example, base expo, right? We can say, and I just told you the third parameter, right, cache. If cache has key expo, return cache expo. And otherwise, do expensive work, right?
Question here. I want to know what is cache here and how to have the cache.
Yeah, this cache is just the map that we're talking about. So for example, if we're to expand on this a little bit, this is our base case, is if we have seen the problem before. If we have the key expo, this is the second case, right? So in the second case, we already calculated 2 to the 5. Now we're trying to calculate 2 to the 5 again. But guess what? We stored it previously. We can just return it. Right now, let's say the first time we haven't seen 2 to the 5. We had to calculate it, right? So we have to calculate 2 to the 5, right? So the way you do, we call pow 2 4. Sorry, 2 2, right? So pow 2 2 times 2, right? So we go do this. Double val equals this, and then so now we can do this, right? Do this, blah blah blah. Does the same thing. Now when we get the value, we do this, right? Cache put expo val, right? This is what we say, right? Put 2 5. This is what we're doing here, or we're putting 532, right? This way, when we calculate this call, the first subtree of 2 to the 5, we will store the result into the cache. And in the second time we call pow 2 5, the cache will have the value of 2 to the 5 inside it already.
Okay, I get. Okay, I know.
Right. So every time we call pow, we pass the same hash map, the exact same instance. Yeah. And so this way, every time pow wants to run, we just first check if we have seen the subproblem before, and if so, we can just return the previously generated answer.
Okay.
So this right here is just it's just a minor piece of intuition for the recursive case. Okay, great.
Cool.
Let's quickly, so this will be it for the mock interview. I want to spend a bit of time here to also go through some feedback if you'd like. and just to talk about some of the things that went well in this interview as well. How do you feel overall?
Uh,
Any thoughts on your side? You don't have to have thoughts. I'm just curious if you have any thoughts.
yeah, I'm just did just like I feel like I have learned a lot from this function because that initially that you give me that kind of function requirement to finish, but I feel like it's a very easy question, but I didn't expect that there will be many things to follow up. So yeah, and
Mm-hmm.
yeah, that's what I feel.
For sure, yeah. This is one of those a classic problem where the math is actually very easy. Like you only need to know a couple exponent rules to do the entire problem, but the
Yeah,
intuition that you can demonstrate by solving the problem efficiently is sort of what separates the different candidates and whatnot, right? So this is a good math. This is a good problem. It's not actually a very strong. It's not actually a math problem. Actually, people get that confused. This is actually a problem about how do you improve complexities of common functions, and also how do you actually calculate complexities, right? Because for example, you made a little mistake early on, right? About
yeah,
how you thought you had an exponential time reduction, but it was actually still linear, right?
yeah,
That's a pretty common pitfall a lot of people fall into. So
yeah,
that's a common thing. You have to always check yourself, right? If you have a
yeah,
loop and a loop is still a factor of the input, that's still the same thing, right? But you caught that yourself after I pointed it out, so that was quite good. Um,
yeah.
Okay, let me just quickly go over some other notes before we call it. So, a couple things at the beginning I think that could have saved you a bit of time, right? So this is before the follow-ups. This is the original question. When you're given sort of, when you're told to implement a function, so in this case you took good notes at the start. There's two inputs of the function. And they're both number types. Like one's a double, one's an integer. In this case, if this is true for all questions, you should always ask what is a range of the input, right? So in this
Oh,
case, you
yeah.
should ask what is a range of the base, right? Obviously, is it able to be? It's double, so it can be it can be zero, it could be positive, it could be negative, it could be integer, it could be a float, right? So you should ask what is the range of the input, right? Exponent as well, right? What is the range? Because integers can be positive or negative or zero, right? So if you get a question with a numerical input like this, you shouldn't even wait. Just immediately ask what is the range of the input, right? And this is also true for lists, right? Oh, if it's a list of integer, ask the integer questions, right? Like I just said, and then ask what is the range of the list? Can it be empty? Can it be null? Okay, what's the size? Whatever, so these things. So whenever you get these sort of types, you should always just ask these common questions. So that's the first thing, which would have saved you about 3.5 minutes or 5 minutes or so.
Okay.
Another thing,
Thank
which is
you.
that you caught a lot of your own bugs after you wrote a test for it, right? But
Mhm.
you shouldn't have to write a test to know you had a bug, because that just means you forgot. That doesn't mean you don't know. That means you forgot, right? So to prevent yourself from
Mhm.
forgetting, you should write the test first. Like write the test before you write the function, right? That way you can spend all your power at the beginning thinking of the common edge case that you need to handle, and that way during when you're implementing the actual function, you have all these cases on the top of your mind, so you can check yourself if it's going to be correct or not, right? Otherwise, if you just write the function, you don't know if it's correct, like you have no idea if it's correct or not before you test it, right? So flip it around, write the test first. Now,
Mhm.
um, depending on the interview setting, you might have to. Some interviewers will actually make you write tests. So no one will ever make you write JUnit, right? So JUnit's not part of Leetcode, but test in this case just means input and expected output, right? Some interviewers will make you actually write valid Java code, like I did here. I made you write the actual Java code. Some interviewers, especially if it's a whiteboard, like you're writing stuff on pen or on whiteboard, they won't make you write
Mhm.
valid code, but they'll at least make you write the input, like what is to, what is base, what is expo, right? But either way, regardless of what it is, you should still write that out ahead of time, because that will help you think more about the implementation in the future. It's the same amount of time, right? It's the same amount of time you spend writing both things, but it makes you look better because you have less holes in the implementation later on. So just flip that around.
Mhm. Okay.
And
Thank you.
one last thing I'll say, which is, I had a, what was it that I said? Yeah, well, one thing I say, which thing was actually quite good, was that you were always asking to make sure things were correct. Like you were always checking to make sure that you thought you were correct, and also you were asking
Mhm.
questions about the ideas that I said, right? So this is a thing which
Mhm.
I think is really good in terms of collaboration and communication aspect, which is that you should
Mhm.
always continue doing this. By the way, is that if you're not actually sure about what the interviewer is proposing, as a hint or as a direction to pursue, you should always make sure that you are 100% clear on it before moving on. Because
Mm-hmm.
otherwise, it'll look really bad if you say, oh, okay, let's do that, but you don't actually know what you're doing, and then the interviewer's looking at you doing that. It's like, what is the person doing? Like, this is not correct, right? So
Mm-hmm.
it looks less bad for you if you spend more time, even if you feel like it's a waste. If you spend more time making sure you actually understand what's going on. So that's a tip which I think you did pretty good here, but I think you can also just keep working on the future as well.
Okay.
Okay, any
Yeah.
last thoughts from you?
Mm, I don't have any questions, and thank you for your time.
Okay, great. It was nice having you on.